Okay, here we are. We're practicing on question number 43 from the benchmark we took on Monday. And the question says, Arturo is playing a board game with 4 cards of each of the following colors: blue, yellow, red, and green. He draws a card from a full deck of those 4 cards. And then without replacement, he draws a second card. We want to know what the probability that he drew 2 blue cards is. Okay, so I'm going to use the strategy we called UPSE. I'm supposed to be teaching that to you guys. That's Damon in the background. He's helping us working out here. U stands for understand the problem. Make sure we understand the problem before we even start working on it. P stands for plan how you're going to solve the problem. S stands for actually solving the problem. And E stands for evaluating and checking your work. Okay, so this is just a strategy about how to work a math problem. It works for any math problem. It works for all of them. Okay, so first things first. Let's make sure we understand the problem. So what's the problem asking us to find?
The probability that he would draw 2 blue cards.
Okay, so I want to write that. So I want to understand, let's see, what is the probability? I'm going to use shorthand here.
But what I don't get is that how many cards are in the deck?
Blue cards. Okay, so I want to know what is the probability of getting 2 blue cards. So you're right, Damon. We need to know how many cards are right in the deck in order to answer the question. So let's see if we can figure that out from here. It says, it tells us he's got 4 cards of each of the colors, right? So he's got 4 blue,
4 blue,
4 yellow,
4 red, and
4 red, and 4 green. I'm going to go ahead under my P, my plan. I'm going to just write that out. So he's got.
So he has 16 cards.
He's got 16 cards. He's got 4 blue.
So then he would have
4 yellow,
1 over 16.
4 red, and 4 green.
Because 4 and 4 is 8, and then the other 4 and 4 is 8. So that makes 16. And the chance of him pulling 2 blues out would be a 1 out of 16.
Well, I'm not so sure about that though, because so the first time he takes a card out, right? He wants a blue card, right?
Oh.
So probability. Remember, probability is what you want.
Oh no! It would be
out of the total. There you go.
Yeah, 4 out of 16.
4 out of 16. Okay, so my probability the first time will be there's 4 blue cards, right? I'm going to put that under solve.
Another one, it would be another 4 out of 16.
But hold on, you might think so, but here's the kicker here. So Demont says, well, isn't it the second time? It's going to be 4 out of 16 too, right? But look at this. Without replacement, that means he keeps the blue card that he took out, he keeps it out. Okay? So if you take a card out of a deck, if you have a deck of cards and there's 16 of them, but you take one out, how many are there now?
That would be a 7 out of 16 chance.
No, there's not 16 cards anymore, though.
3.
Yeah, it's 3 out of...
That's 3 out of 16.
No, there's not 16 anymore, though. So here's the thing. There's 4 blue cards out of 16, right? But you just took a blue card out. So how many blue cards are left? 3 blue cards are left. And how many total 15. Cards are left? There's 15, right?
Yeah, 3 out of 15.
Okay, so that's our two.
Yeah, it just
our
takes
2 fractions
on the numerator and the denominator.
Yeah. Yep. So since this is a compound event, he has to draw both blue cards. It's a compound event. We have to multiply these together.
Oh,
now, before you multiply, you might want to reduce them. I want to simplify them. Because this is going to be hard to multiply. I don't know what 16 times 15 is.
That would be 2 and 8.
Yeah, so
4 over 16 would be 2 over 8.
Okay, so both 4 and 16 are even. So we can divide them by 2. So that becomes 2 over 8. But that's still not fully reduced. Simplified.
1 over 4.
1 over 4. Okay, because both 2 and 8 are both even. So that becomes 1 over 4, right? How about 3/15? Can we reduce out?
No. Maybe the 15. I don't know.
Can you divide 15 by 3?
Yeah.
Sure. What's 15 divided by 3?
15 divided by 3. 4?
No.
No. 5.
5. Okay. So 3/15 is 1/5.
Okay, so that'll be...
and now we multiply these together, right?
Yeah.
1/4 times 1/5. Remember, with when you're multiplying fractions, you just multiply straight across.
So it'd be 2 over 9.
No, we're not adding straight across. We're multiplying straight across.
Oh, multiplying. So that'd be 1 times 1 is 1. And then 4 times 5 is 20.
20.
So
Yep.
it's 1 over 20.
So that's our answer. And so we're looking for answer choice. In this case, it would be C, right? 1 out of 20. Okay, I also want to just real quick, I want to solve this one using a tree diagram too, because some students might forget that when you have a compound event, you multiply them together. So we could do this with a chart, which is what we learned about today, at least in my regular math class, or with a tree diagram. Let's take a look at the tree diagram, okay? So my tree diagram, remember, this is kind of like the alternate universe, right? So imagine that every decision you make, maybe I decide to go to HEB or Walmart, right? In some parallel universe, there's a Mr. Baker going to Walmart. And in a different parallel universe, there's a Mr. Baker going to HEB. Can you imagine that? Like branching off. So now there's some place there's a Mr. Baker going to each one of them, right? So I like to use that idea of the parallel universe because in this case, right, here's whoever this is, Arturo. Okay, Arturo is sitting right here. And he has a decision to draw a card. And in one parallel universe, Arturo draws a blue card. In a different parallel universe, he draws a yellow card. In a different one, he draws a green card. In a different one, he draws a red card. You imagine that? Okay, so there's Arturo. There's his tree diagram for Arturo's first. Okay, for his first drawing a card, and then for his second drawing a card, the same thing happens, right? So branches off 4 directions. Okay. So here's a tree diagram with 2 different events. The first one is drawing a card. The second one is also drawing a card. And again, every one of these is also, he could get a blue, he could get a yellow, he could get a green, he could get a red. And the red. Excuse me, okay. So now we look at the probabilities, right? So the probability, okay, so what is the probability of Arturo starting out? He hasn't done anything yet. What's the probability of drawing a blue card? Well, it is, there's 4 blue cards out of 16, right? I don't really even care about these ones because remember the question's asking about drawing 2 blue cards. So you could, yeah, this one's 4 out of 16 too, and this one's 4 out of 16, and this one's 4 out of 16. But guess what? I don't care because I'm only interested in the blue ones. I'm only interested in this parallel universe one where Arturo actually draws the blue one. The other parallel Arturos, I don't care about them. Sorry. Okay, so this guy, and then again, this is exactly what we just did over here, but now we're breaking it down in a tree diagram. So now that he's taken a blue card out, what is the probability of taking another blue card out? Well, he already took 1 out, so there's only 3 left, right? And how many cards are there total if he just took 1 out? Well, 15. Okay? And we could do the rest of these. This would be, let's see, if he took a blue one out, then there's be 4 yellow ones left, so that'd be 4 out of 15. That'd be 4 out of 15. That'd be 4 out of 15. Interesting side note, by the way, if you add up all of these, they should always add up to 100%. So 3 plus 4 plus 4 plus 4, 15, should give you 15 fifteenths, which it does. Okay. Just like when you added up all these, they should give you 100%. Anyway, all right. And then I look at the Arturo that I want. Out of all the parallel universe Arturos, the one I'm interested in this is the guy who first drew a blue one, and then he drew another blue one. And I want to know how likely that was. I guess you still have to know. You got to multiply these together. If you don't remember that, I guess you're kind of stuck. Yeah, I don't know how else you would do it. Yeah. But this also gives you a picture, which I like the picture, right? And that's, we got 27 seconds left, it says on my screen, before we got to stop the video. I'm glad it tells me, right? But that's our picture now of this parallel universe Arturo. He's got a 1 in 20 chance of existing because the other 19 Arturos in the other 19 parallel universes didn't get 2 blue cards, right? So hopefully this kind of refreshes your memory of what we've been learning this week. And I have 5 seconds left, so we'll see you guys later.